Okay, so on this one, we have got it says rationalize the denominator. So notice we have a square root in the denominator. So here's the rule. Let me put the rule up here. The rule is that we never leave a root in the denom. It's okay in the top. Root is okay in the top, not the bottom. Right? So okay, so instead of leaving a square root in the bottom, you multiply by instead there's two cases. Case one, root. Well, let me say. Okay, so if the denominator has a root and no adding, subtracting, root and no adding, subtracting, multiply by root over root. But then case two, I'm running out of room here. Case two, denominator has root with adding, subtracting. That's what we have. See this little adding, subtracting, it's gonna make a big deal. You have to multiply by number, opposite sign, root. Number, opposite sign, root. Top and bottom. This even has a name. It's called the conjugate. So I'm not going to quiz you on the name, but let me show you what we do. So I'm going to come in here. I'm going to multiply, not just by root 5 over root 5. That's not going to work. That will not get it done. Why? Because of this minus sign. That's the big deal. As we've seen in many other situations, pluses and minuses, adding, subtracting always makes things more difficult, right? So case one, if you just have a denominator with no and a root, a denominator with a root and no adding, subtracting, no big deal. Just multiply top and bottom by the root. But case two, if your denominator has a root with adding, subtracting, that's a lot harder. You have to multiply by something called the conjugate, which means number, opposite sign, root. So I'm going to go 6 plus root 5 over 6 plus root 5. See how I took the sign that's in the middle and I did opposite? So if the original sign had been plus, I would be using minus top and bottom. Does that make sense? Opposite sign in the middle. Okay, now, let's put parentheses here. Now we have to just multiply this all the way out. So let's see, what will this equal? So on the top, this minus 2 is going to go there and there. So minus 12 minus 2 root 5. See what happened there? This minus 2 times 6 made minus 12. And then when the minus 2 multiplied the root 5, it had to stay in the front because remember, outsiders interact with outsiders, insiders with insiders. So this 2 and minus 2 and root 5 stay separated because the 5 is an insider, the minus 2 is an outsider. Now on the bottom things are more complex. We got to go to both like this. 6 times 6 is 36 plus 6 root 5. And then he's done. He went to both. And now it's this guy's turn. He's going to go to both. Minus 6 root 5 minus root 25. Did you track with all that? So we got 4 terms down here. First, the 6 went to both. Remember, outsiders multiply outsiders, insiders with insiders. There's no crossing the line like prison, right? Outsiders with outsiders, insiders with insiders. So I made 36 and the 6 root 5 stayed separate. Outsiders outside, insiders inside. And then this minus, remember this is a minus. When you do the multiplication, remember that minus is really on that root 5. And this plus sign is really on that root 5. And so when this minus root 5 goes to 6, it's minus 6 root 5, and then minus root 25. Okay, what becomes of that? Well, what becomes of that is some good stuff. Now what we get, look right here. On the top here, nothing's really happening on the top, nothing special. On the bottom, see how these cancel? Because they're opposites. See that? That's beautiful. We have minus 6 root 5 and plus 6 root 5. That's beautiful. That's why it's up beautiful. We want the roots to go away. And so that root went away. And we have 36 minus, and what's the square root of 25? 5, no more root, right? Square root of 25 is just plain 5. No more root. You can do the root. You can root 25. And so you do it. You root the 25 and it's gonzo. And so what does that give us? Now we have on the top, minus 12, minus 2 root 5. On the bottom, 36 minus 5 is 31. And we're done. The box around it. We did. What did we accomplish? No more root in the bottom. We got rid of the root from the bottom. So let's backtrack, talk it out for a second, because this is definitely a harder situation here. So if you have, so the rule is we never leave roots in the denominator. They're okay in the top, not in the bottom. So instead, how do we get rid of the root? Well, case 1, if the denominator just has a root and no adding, subtracting, that's easy. Multiply top and bottom by just the root. But case 2, if the denominator has a root with adding and subtracting, like ours did, ours had a root and had adding, subtracting, right? Then you've got to multiply by more. The number opposite sign root, number opposite sign root, top and bottom. Same thing, top and bottom. So you take the whole denominator, but you put the opposite sign in the middle. So we did that, and then you distribute on the top. Remember, outsiders with outsiders, insiders with insiders. On the bottom, it's a whole FOIL, first to both, second to both. And then these cancel. As you see, that's why we used opposite sign. See how that worked beautifully? You have one positive, one negative. So they went away. Remember, we're trying to get rid of the roots. That's why that works. That's why we use the opposite sign, because that makes these guys opposites and they go away. And then the root of 25 just becomes a plain 5. So there's literally no more roots in the bottom. And so there we go.